I will go through the presentation to tell you a little bit more about the courses and all this programming structure. Okay, so the first slide is about like the overall structure of this program. So the Computer Science MSc program, we like to say that spans the range from computer systems through theoretical computer science, in the sense that takes over many different topics in the computer science discipline, and specifically the one that are here in this slide depicted in the picture are what we call computer science foundation, system, and software. So this first group of courses that we'll go through later, I mean, currently has more or less 22 preselected courses, and you have to pick between 60 and 100 credits of those courses. So then, okay, it doesn't go. Okay, so maybe I do like this. Then there is another group of courses that is called CS Non-Foundation, System and Software. And this includes courses such as ML, AI, ethics, NLP, speech, bioinformatics, neuroscience, computational data science. In this group of courses, you can select between 0 and 40 credits. So you can also select 0, so no course. And here, usually there are around 14 courses. Okay, so other than that, you can also select courses within the programming block. So here, there is actually only one course at the beginning, but like a couple of years ago, there were more courses. And then we have courses in informatics and math, and you can select between 0 and 20 credits here. And these courses must be level 10. And also, there are several system and theory courses that are suggested in this group, such as, for example, my course that is operating system. And then you have another block here. Actually, sorry, I just figured out that I wasn't doing the laser. That are courses in all school that includes informatics and math, but no medicine, veterinary studies, and COL. So here you can select between 0 and 20 credits. Okay, so just to give a sort of summary of this slide. So this slide shows you that you have in which sort of topics you can take courses in your program. And we said that there is this CS Foundation in which you have to take at minimum 60 credits, but you can take up to 100 credits. And then there are also the other blocks that are actually optional, because see, you can take between 0 and 40 credits in CS Non-Foundation, 0 and 10 to programming, 0 and 20 in informatics and math, and 0 and 20 between all the other schools. Okay, so now what I will do in the next slide is to go through the CS Foundation System and Software, also called FSS courses. Okay, but obviously because I clicked the wrong thing, now I have to do like this. Okay, so these courses are about database and data management, human-computer interaction and design, software engineering, theoretical computer science, quantum informatics, cybersecurity and privacy, and computer systems. So let's go through each of these. And as Samantha wrote before, if you have any question, maybe you can start writing those questions already in the chat. Okay, so the first group of courses is the computer system courses, and this is like in our slogan, spans the range from computer system to theoretical computer science. This is the most low level of the computer stack. So basically here we are going to talk about the practice, the design, but also some theory about optimizing and programming computer system from the low level. So from embedded system like Internet of Things, IoT, cloud and edge data center, but also high performance computing, where I mean, today we may run weather forecasts, but also AI. So here there are several courses, such as Principle and Design of IoT Systems, Applied Cloud Programming, Machine Learning System, Parallel Programming Languages and System, and Distributed System. So these are the ones at level 11. Okay, so the next group of courses is cybersecurity and privacy. This is about security. I mean, I think everyone should know about security today. We don't want our data, our personal data, such as our bank information, but also our email to be stolen, or our identity to be stolen. Therefore, security is very important, but also the privacy. So an additional topic that actually is very important today is blockchain. And basically, blockchain is like all to track things in a way that can be proven securely. So here some courses are like blockchain and distributed ledgers, security programming, introduction to modern cryptography, quantum cybersecurity, and usable security and privacy. Okay, so I go to the next pillar, that is database and data management. I think everyone knows then our data is stored somewhere in the internet, right? But then how do we build these systems that are able to store the data? And here is where databases and data management software comes in. But it's not just about the software, or we build the software, or we design the software, but also the theoretical aspect of that. So like also the data structure, but also the algorithm to deal with all this big data. And obviously the practical aspect about how we distribute it, for example, on multiple machines. So about this, we have several courses such as Advanced Database System, Machine Learning System, Distributed System, and Modeling Concurrent Systems. Okay, so the next pillar is software engineering. Software engineering is important. Why? Because we want to make our software usable and also design our software well so that it's even more usable, right? But then also our software must not contain any bug. Therefore, we need to test the software and potentially also do something more interesting, that is formal verification. And then obviously there is about software management. So how do we, for example, do implement this software, but also not just by ourselves, but also in a group like Git. So for this type of courses, we have applied cloud programming, computer graphics rendering, computer graphics geometry and simulation, and text technologies for data science. So the listed courses, while they are not specifically about software engineer, they are not all specific about software engineering, there are significant programming or development components so that it could be relevant for students that want to practice their software engineering skills. Okay, so this moves me to the next topic, that is human-computer interaction. I think we all understand the value of that, right? So we have our mobile phones. Okay, so it's blurred by my background. And the mobile phones slowly entered the usage of everyone, like sorry, actually I want to say slowly enter our daily life, and everyone is using them, right? So from your age, that you are very young, from my age, and also from the age of my parents. So they are usable, they are very easily usable because there are many people studying human-computer interaction. So here you want to study theoretical and practical aspects of human-centered approach design of so the systems and the interfaces. Always with the design, so always design with the user in mind, and also using, evaluate the system usability of the software. So for that, we have courses such as case studies in design informatics 1, human-computer interaction, and also usable security and privacy. Okay, the next course, the next set of courses that I want to tell you about is about quantum informatics. I think that today, many people talk about AI, but also many people talk about quantum. Quantum technology is something that become more and more interesting in the latest years. Therefore, this is why there is also a quantum software lab at the school, and it's important to kind of start studying quantum and also for possible jobs in the future, because it's becoming more and more interesting. Also, there are more and more companies. So exploiting quantum effects to manipulate information in novel ways is what we want to teach. And there are several aspects of it, such as quantum information theory that can start from physics, the communication between different quantum computers, all the computation actually in quantum computing works, and also the security aspect when quantum computing comes out, because as you may have heard, quantum computer, because they are particularly good in doing certain type of computation that are difficult for classic computer, they are actually like alarming people that are working on security, because they think that quantum computing can help solving security, I mean the cryptography actually, much faster than classical computing. So here we have several courses such as Introduction to Quantum Computing, Introduction to Quantum Programming and Semantics, and Quantum Cybersecurity. Okay, the last course in this group of, set of group of courses is theoretical computer science. So this is, in some sense, the end of the spectrum from the point of view of our courses that we offer. That I told you, like the computer system is like at the very end of the spectrum, in which is very low level, and instead theoretical computer science is very high level. So here we want to study like what is computation, how to design new algorithms, and how to analyze algorithms, and how we can know if our algorithms are faster than others. So that basically analysis, but also the computational complexity of this algorithm. So many of these theoretical computer science courses have strong mathematical backgrounds, and some examples of these are types and semantics for programming languages, machine learning theory, algorithmic game theory and its application, modeling concurrent system, and security and privacy courses, as well as quantum informatics courses. Okay, so now that I show you all these courses, we can switch to this other slide. So about the credits. So in total, you have to get 180 credits. So you can get between 60 and 100 credits in this CS FSS. You will get 80 credits in this informatic project proposal, informatic research review, and your dissertation. So your dissertation is 60 credits. So you will do your dissertation with one of our faculties, potentially including me, or you can do a self-proposed project. I don't know if this has been discussed before, but basically a self-proposed project, you potentially in accordance with another professor, you can discuss and write down your project proposal, and then that project proposal will be taken over, and one of our faculty will help you with the supervision. So informatic project proposal, informatic research review are two courses that help you to get ready to do your project, such as how you do research and how you seek for papers or other material that can support your thesis in your project. Okay, then there are, then there are these programming courses that can give you from 0 to 10 credits, the CS non-foundational and system software courses between 0 and 40 credits, the informatics and math between 0 and 20 credits, and the courses in all other schools between 0 and 20 credits. Okay, so let's go to the next slide. So here I show you some information about like how you can get more information about the courses, but basically you can go in the degree finder and look for the computing and informatics first. Then you look for Computer Science MSc, and then you will end up in a page similar to this, in which the breakdown of all the courses is visible, and you can basically read all the other information related to it. So here I talk about the program structure and the courses that are more or less overview to you already. Okay, so there is this also the RPS that allows you to look at the courses, and here they are organized just in a different way. So actually here I find this way much more convenient than the others, because here actually show you all the courses that are running this year, and also more information about the credits and the semester. Okay, there is also the MSc handbook, which I suggest you to read, and goes a little bit more in deep about how the program works. Okay, so said that, I think we can go towards the questions, but I just want to conclude by saying, when do you want to choose an MSc in computer science? I mean, when basically you are interested in all the different layers of computer science, right? From the low level to the high level. So you are interested, for example, in computer system, but database or human-computer interaction, software engineering, cybersecurity, quantum and theoretical computer science. So actually, we want to say that this MSc program provides you with a broad perspective, differently from other programs such as AI. And also is good for the people that, for example, don't know yet what they want to do in the future, because here they get a broad exposure to the different topics.